Have you ever wondered what's really going on inside the mind of an AI? We're always told, oh, it's just predicting the next word. But let's be honest, that explanation feels a little flat, doesn't it? Today, we're going to dive into a powerful new metaphor that might just change how you see artificial intelligence forever.
So yeah, this is the central mystery, right? When you prompt a large language model, the experience feels so much richer than just a simple prediction engine. It feels like you're tapping into this whole system of meaning. But how does that system actually work? That standard answer just doesn't capture the magic or, let's face it, the occasional weirdness of what's happening.
And this quote from the source material just nails that feeling perfectly. You're not just pulling a book off a shelf in some massive digital library. It's way more dynamic than that. It's like you're sending a ripple through a system, creating a semantic interference pattern, and then just seeing what comes back. This whole idea of disturbing a field, instead of just retrieving a fact, that's the key to unlocking a whole new way of understanding this.
Now, to really get a handle on this, we're going to take a little detour into a completely different world, sound engineering. I know it might seem totally unrelated, but trust me, it holds a brilliant analogy for what's happening inside an LLM.
So, check this out. It's an idea based on something called the Fourier transform. On the left, you've got a raw sound wave in the time domain. It just looks like a jumbled, chaotic mess, right? But the transform, it's like a magic decoder. It takes that mess and turns it into what you see on the right, a clean, structured set of frequencies. It basically reveals the simple individual notes that were hiding inside all that chaos. And this is the profound insight we can steal from sound waves. The chaos of the wave and the structure of the notes, they're really just two different ways of looking at the exact same information. So that begs a pretty fascinating question. What if we could do the same thing for language? What if we could find the hidden structure inside the chaos of words?
Okay, so this brings us to the absolute core metaphor of this whole explainer, the semantic prism. This is where we connect all those dots between sound engineering and AI and get to that big aha moment.
So, let's just start with this idea. Imagine for a second that every sentence, every book, all the text the AI was ever trained on, imagine it's not a string of words, but one single, incredibly complex signal. Let's call it a semantic waveform, containing all those overlapping meanings and concepts all jumbled together.
And here's the kicker. What if the large language model itself is basically a prism? You know how a glass prism takes a beam of white light and splits it into a beautiful rainbow of colors? Well, what if the LLM does that for language? It takes that complex waveform of meaning and breaks it down into its fundamental components.
This quote just illustrates the whole idea so perfectly. Your prompt is the beam of meaning. The AI's neural network is the prism, which has learned the very structure of how meaning works. And the output, the next word it picks, that comes from a spectrum, a whole rainbow of possibilities for what could logically or even creatively come next. Okay, so that's a beautiful metaphor, right? But how does it actually map onto the technical bits and pieces of an AI? Let's take a look at how this poetic idea actually builds into a functional model. This table lays it all out pretty clearly. The waveform we're talking about, that's your prompt. That's the input signal. The prism, well, that's the neural network itself, the whole trained model. The act of projection, breaking the wave down into its parts, that's what the attention mechanism is doing. The spectrum, that rainbow of possibilities, is the list of token probabilities the model spits out. And finally, reconstruction is the single word that gets chosen from that spectrum and becomes the output. It all lines up.
So why does any of this matter? What does thinking about AI as a semantic prism actually help us understand about its behavior? Well, it turns out it gives us these really intuitive explanations for some of the most fascinating and frustrating things that LLMs do.
Let's talk about hallucinations. When an AI just makes stuff up. In this model, that isn't really a bug. It's something called spectral leakage. Think of it like two musical notes that are so close in frequency they kind of blur together. In the AI, two concepts are so close in this semantic space that their meanings literally bleed into each other, creating a statement that sounds totally plausible but is actually wrong.
This model also explains how an AI can say something it's never actually seen before. It's not just copy-pasting sentences from its training data. No, it's operating in that frequency space, and it can actually interpolate between known concepts, or semantic frequencies, to generate a totally new idea. It's just like a musician playing a new chord by combining notes they already know.
And this completely reframes what we mean by AI creativity. The model isn't some database just replaying information it has stored. It's an instrument, recomposing meaning from its most basic semantic parts. Real novelty emerges from this process, from resonance and reconstruction, not just from looking something up in its memory.
And if you take this idea all the way, it implies something that is truly mind-bending, that there is a geometry of meaning inside the AI. Concepts aren't just words, they're like coordinates in a huge multi-dimensional space. The distance between 2 points shows how different the concepts are. The angle between them shows their similarity. You can even do a kind of conceptual math, where making an analogy like king is to queen as man is to woman is as simple as moving a vector from one point to another. It's wild.
So, what's the big takeaway here? The semantic prism isn't just a clever analogy. It really represents a fundamental shift in how we should think about and, more importantly, interact with this technology. Let's just compare the two views side by side. The old view sees AI as a static database, right? A giant library where you look things up. It's totally passive. But this new view sees the AI as a dynamic instrument, like a piano. A piano doesn't contain music. Its structure just allows music to be played. In the same way, the AI doesn't contain an answer. Its structure allows an answer to be composed.
And this quote from the source just says it all, loud and clear. We need to stop thinking about AI as a thing we just query for facts that are stored somewhere. We need to start thinking of it as an instrument that we play. And that changes everything, from how we write prompts to what we can even expect from the interaction.
And this brings us to our final and maybe most provocative thought. If the AI is an instrument, then where does the meaning actually live? It's not stored inside the machine's code. You can't just point to it. The idea here is that meaning emerges in the space between us and the machine, in the very act of interaction, in the resonance we create together. So the question becomes, what does it mean for us as we move forward to be co-creators of meaning with these new semantic instruments?